Have you ever just looked up at the night sky and wondered, how did our ancestors make any sense of all this? Well, it turns out that asking really simple questions about the moon and stars can lead to some truly profound discoveries about our planet and, our place in it all. So today we're going to go on a little journey from ancient timekeeping all the way to modern ecology, all powered by one simple tool: observation. And our journey starts with a question you might have even asked yourself.
Let's kick things off with something a little personal. If you happen to be born on a full moon, what do you think the odds are that your 18th birthday will also have a full moon? It seems like it should, right? I mean, it's a predictable cycle, but the answer, well, it's a bit more complicated, and it gets right to the heart of this beautiful mismatch in our celestial clocks.
So why doesn't it line up perfectly? Well, the thing is, we're essentially trying to jam one natural clock, the moon's cycle, into a totally different one, the Earth's orbit around the sun. And spoiler alert, they just don't sync up very neatly.
Here's the deal. The lunar cycle and our solar calendar are kind of marching to the beat of two different drummers. A full lunar cycle from one new moon to the next takes about 29.5 days, so a lunar year comes out to about 354 days. That's a full 11 days shorter than the 365.25 days it takes the Earth to make one trip around the sun. It's because of this gap that the full moon seems to wander across our calendar from year to year. Your birthday stays put, but the moon's phase on that day, it's always changing.
This exact problem, trying to track these different overlapping cycles, is precisely why we invented calendars in the first place. For thousands and thousands of years, humanity has looked up to the sky to find its clocks.
And when you think about it, our most fundamental units of time aren't man-made at all. They're based on these huge, predictable celestial events. A day, that's just one spin of our planet. A month is roughly one orbit of the moon around us. And a year, well, that's one full lap for the Earth around the sun. These are the natural rhythms that have governed life for, well, forever.
And here's the cool part. You can actually get a feel for these rhythms with a super simple model. Seriously, imagine for a second that you are the Earth, and let's say a lamp across the room is the sun, and a ball on a stick is the moon. If you hold that moon out and just turn around in a circle, you can actually recreate the entire lunar cycle right there in your living room.
As you turn, you'll see the light from the sun hitting the moon from different angles. You'll see little crescents, a half-lit phase, and then a fully lit full moon when the ball is directly opposite the lamp. And this simple experiment proves something huge. The phases aren't caused by the Earth's shadow. They're just our perspective, our point of view of the sunlit half of the moon as it orbits around us.
Okay, so we've established that the moon's cycle doesn't fit perfectly into our year, but our main calendar has its own little quirk. A year isn't exactly 365 days. It's about a quarter of a day longer. Now, we solve this with a leap year every 4 years, but what if we didn't? What if we just stopped?
Without leap years, our calendar would slowly but surely drift completely out of sync with the seasons. Every 4 years, we'd be off by a whole day. It doesn't sound like much, but over centuries, it would be a total mess. Can you imagine celebrating a summer holiday in the dead of winter? It would take a while, sure, about 732 years, but eventually, August would be a winter month. That's the power of that tiny quarter of a day.
So what this all really hammers home is that accurate observation is everything. It helps us build calendars and understand how the heavens work, but it also helps us bust some pretty common myths, because, let's be honest, sometimes what we think we see isn't quite right.
I mean, think about the classic image of the night sky you see in like a children's book. You've got a crescent moon, maybe a few clouds, and a sprinkle of stars. It feels familiar, cozy, right? But what if I told you there's something fundamentally wrong with that picture? So, can you spot the mistakes? Think about what you actually see when you go outside and look up at the sky. There are two really big errors in this common drawing.
All right, first up, the sky is lit, which implies it's daytime, but you can see stars. Nope, except for our own sun, other stars just aren't bright enough to be seen during the day. And second, the shadow on the moon is drawn in a way that suggests it's the Earth's shadow causing it. But as we just saw, that's what a lunar eclipse is. The regular phases are all about our viewing angle. It's a perfect example of how just casually looking can lead to big misconceptions.
And this brings us right to the core of this whole explainer. The same power of observation that allowed us to chart the stars and build civilizations is now desperately needed to understand the interconnected cycles happening right here on our own planet.
So let's bring it back down to Earth. Because just like celestial bodies are linked by gravity, life on our planet is connected in this incredibly delicate interlocking system. And when you mess with one piece, the whole thing can start to come apart.
I want you to consider this chain reaction. It all starts in a small farm pond. Let's say the aquatic plants start to die off. So what? Well, then the fish that depend on those plants for food and shelter also start to decline. But the effects don't just stop at the water's edge. With fewer fish to eat them, the insect populations on the nearby farm can just explode, and that forces the farmers to use more pesticides, which can then run off back into the water, making the whole problem even worse. It's a vicious cycle.
So the big takeaway here is this: interdependence is everything. When we cut down a forest or pollute a river, we're not just removing trees or making the water dirty. We are breaking critical links in these ecological chains. This kind of habitat destruction is one of the biggest reasons we're losing biodiversity.
Scientists actually have a name for what happens when you add all this disruption together. They call it the triple planetary crisis. It's this nasty combination of climate change, biodiversity loss, and pollution. And at its heart is a problem of speed. Human activities, especially burning fossil fuels, are pumping carbon into the atmosphere much, much faster than the Earth's natural systems, like our forests and oceans, can ever hope to absorb it. We're throwing the planet's natural rhythm completely out of whack.
So what does a full moon on your birthday have to do with any of this? Turns out, everything. It all comes back to the power of careful, patient observation. It really boils down to this one simple truth: nature works as a system. Every single species, from the tiniest plankton to the biggest whale, has a role to play. And when one part is removed, the entire system gets weaker.
That scientific mindset, that simple curiosity to watch and to measure and to understand cycles, is one of humanity's greatest tools. It's the very tool that allowed ancient astronomers to predict the seasons and build calendars. And it is the exact same tool we desperately need today to understand the complex systems of our own planet and figure out how to live in balance with them. So I'll leave you with this final thought. The next time you have a quiet moment, practice that ancient skill. Look up at the sky. Look closely at the plants and insects in your own neighborhood. What patterns do you see? What connections can you find? What can you learn just by looking a little bit closer?
If you're curious to see more connections like these, and I hope you are, please don't forget to like, share, and subscribe. Thanks so much for watching, and keep looking closer.